Okay, TS2 Environment and Energy. This is going to be the last of the exercises relating to looking at your house in terms of environmental performance, and we're going to kind of look at two things in this which carry on from the last exercise involving use of Diva, which is a plugin to Rhino. We're going to look at it in terms of internal daylighting and the relationship that has with sunlight and solar control. So I hope that at this point you will all have built the model of your homes akin to the model of my home that I've built, and I hope that the detail of this model is sufficient, not too much, but sufficient to allow you to do this exercise. So just to recap, the model of my house I say is fairly crude and fairly simple, but adequate for this. And the key thing I need you to have, and you probably already have it, is a level of detail which is captured in very few layers. Now, the only layers that you should have are, as I do, just I'll walk you through these. Let's turn these off. Really 4 layers that I've got. One is the external fabric of my house. One is the internal rooms of my apartment, I just being the ground floor only. I've got the glass on a separate layer, that's really important for this. And then I've put the surroundings on another layer outside of that. So that, as you probably noted in the last tutorial, was important for using Diva in terms of that layer logic. So what we're going to do today is quickly start by looking at the internal illumination, that's the daylighting levels in one of your rooms. So to do that, the first thing you need to do is set up a view. I've already set up a view in mine, but there's a few ways you can do this. The easiest way tends to be to turn off everything except the inside layer. So that's, for me, is that the 3D walls inside. So this is my apartment, and would just simply position myself inside the room that I want to, and this is the bedroom which I'm going to look at today. And usually what I would do is, once I've kind of got into that space, I would go to View, go to Set View, and then Set View, and then under Named Views I would then save a view, Save As, and I would tweak that view in a couple of ways. When you set up a view, that camera will the properties of that camera in terms of its focal length, all these things you can play with. If that number is wide, lower or higher, it'll change the view angle, and just the position generally. So I've done all of that now, and the view that I have, which is Giles' room, is already set up, and I've set that up so that what is captured in my room, if I turn on the layers, is all of these key things. Not very much detail, but I have put a table in there, which is what I want you to do as well. I'm actually just going to put that table on the correct layer. I'm going to move it to a new layer, 3D furniture. And I will just move that to 3D furniture. Okay, so essentially the first part of doing this exercise requires you to simply replicate what I've done, which is to replicate a view in your room. And I do want you to have one piece of furniture, no more than one, as simple as you can, in that room, preferably a table or something which has a working plane on it. Okay, once you've set that up, again, the process for using Diva is super simple, and the steps are the same as they were last time. I'll just run quickly through them. I'm just going to turn that to layers so you can see. Location, again, any environmental simulation requires a location because every environment is different. In the previous tutorial I've told you how to download the location file, or the EPW file, for London Gatwick. So if you haven't got that, go and look at the previous tutorial. So that's just a question of clicking on that and putting it in the right folder, which is the C Diva folder, again all explained in the previous tutorial, and pressing OK for that. We're not doing nodes in this, so we're just going to jump straight to materials. And again, materials under assign materials. All we have to do is assign materials to each of those layers. This is the reason that we have such a rigorous layer layout. So I've already assigned materials to glazing. I've assigned materials to walls and inside walls, and remembering that these numbers here represent the reflectance values. The higher the number, the more reflectant. I have white walls in my house, so I've given them a reflectance of about 70. So the only one I haven't assigned a material to is this table, which I just put on a furniture. So I'm going to assume it is kind of immediate reflectance, so we'll just go generic furniture. The reflectance about 50. And then when you've assigned all of those reflectances, you can just submit material information. So that doesn't change anything in your viewport, but it does mean that now Rhino and specifically Diva know what materials it can take into account when doing simulation. So the simulation that we're going to just do this very quickly is as before, this Diva window pops up, and the one that you're going to look at is under daylighting images, visualization. Last week we looked at radiation map, so under visualization. So this is, you could just simply go with this immediately, just run simulation, but I'll just tell you what some of these are. Image quality relates to how long you want to wait for your simulation. I think for these submissions that I would like to go for the medium quality, that should be enough, but just to make sure it works initially, go for the low quality. I'll just do low quality now so you can see. What is important is a question of the sky condition. Now usually when we are doing daylighting, we would always look at an overcast sky condition for a very simple reason. We want to know whether when it's a miserable day in February, whether we have enough daylight. So I'm going to go with what's called a CIE overcast sky, so I'm going to click on that one. Once you go for the overcast sky, then it's kind of a generic grey sky condition. Date and time don't now matter, so that's fine, so you don't need to touch that. You've got the perspective. You could change and look at fisheyes if you wanted to, and the current perspective view is what it's going to do. So you can have a play with these. This is also something you can play with. For the moment, I just want you to do render illuminance image and tick that box. If you want to know more, click on that. That'll tell you everything about that. Don't worry about this. They're all just radiance inputs which you don't need to play with. You can play with the image size if you want, and really don't worry about any of these either. So all you need to do is press run simulation. Now, as before, when you press run simulation, this dialog box will come up, and then you have to wait. We have to wait till this gets to 100%. So I'm going to pause this for a second. Now, once that has reached the end of its list, which just took me about 20 minutes, I think. And if I'd gone for a higher resolution, it would have taken longer. But at the end of it, no matter what you pick, you'll get to an image, and that image should look. It should look, I suppose, something which I wouldn't. I don't want to use the word photorealistic because obviously this doesn't include any materials, and that's important because it is a measure of when we say illuminance, it's a measure of light falling on a surface rather than light bouncing off a surface. So everything appears grey, and that's very often how we want to look at things, because we want to understand if there's enough light falling on a surface. What surface? Well, maybe the surface of a table, such as this table. And if I just make this big, the good thing about this software is this is what makes it different from if you just did any rendering in any other software. When I click on this one, it allows me to assign values to places where I might be interested in the illumination, like the tabletop. Can I actually read a book? Well, I can read a book. 500 lux is a number that I've mentioned to you, but actually I could quite happily read a book in 200 lux. So can I read a book in this room on this table? Yes, I can. Could I sit under the table and read a book? Well, probably not. And really that capacity is really important for us to understand the performance of a room in terms of daylighting, and it's a function of many of the issues I've discussed in terms of the size of the window, transparency of the window, the proportion of the windows of the buildings outside of that window, and as a result of that the relationship to the sky and essentially the source of light. Now the other thing you can do in this, which I'd like you also to do, is it's very simple. If you click on false color, we can change this image to a different type of visualization, whereby we're not looking at a grey and then a series of points, but we can look at a color range. So if I press that, convert to FC, it will now change this image in a different way, and I can alter the scale of that. If at the moment it's looking at Candela. Okay, so this is looking at luminance. Anyway, let's just go on that. If I reduce that number, the upper range, what you'll find is that it will change the scale and give you much more variance in terms of the kind of colours that you get. So it's worth having we play with this to see, by changing those scale, what you can what kind of image you can get. So that is the first part of the lecture. You can obviously save the image as you want to a JPEG file format or a BMP file format. So right, so they're the first two things I want you to do. So we're going to quit out of that.